Imagine AI agents that learn to cooperate not through hard-coded rules or complex meta-learning architectures, but simply by inferring their partner's behavior from context. This paper reveals how such cooperation emerges naturally when agents train in diverse environments. Building on that foundation, let's examine the core problem these researchers set out to solve. Traditional multi-agent reinforcement learning faces two fundamental challenges: selecting the right equilibrium when multiple stable outcomes exist, and adapting to constantly shifting landscapes as other agents learn. Existing solutions typically rely on expensive meta-gradient computations or architectural separations between naive and meta-learners, introducing significant complexity barriers. The authors demonstrate something remarkable. Foundation model-based agents can achieve cooperative behavior entirely through in-context learning, provided they train against sufficiently diverse opponents. This approach leverages the natural inference abilities of sequence models without any built-in coordination protocols. So how does cooperation actually emerge from this simple setup? The mechanism unfolds in three elegant stages. First, training against a mixed pool of static tabular strategies and adaptive learning agents forces the sequence models to develop in-context inference abilities. The solid lines show robust convergence to mutual cooperation when agents train in this diverse environment. Notice how both ablations fail dramatically. Agents trained only against other learners or given explicit opponent identification collapse to defection, proving that in-context co-player inference is not just helpful but essential. Following that initial adaptation capability, the path to cooperation proceeds through a fascinating vulnerability phase. Agents with strong in-context learning become exploitable by other learners who can extort them, forcing unfair reward distributions. When two adaptive learners meet, they initially engage in mutual extortion, each attempting to manipulate the other's fast adaptation for selfish gain. First, Cume's AI voice generator. Remarkably, this mutual extortion dynamic ultimately drives both agents toward cooperation through bidirectional shaping, operating simultaneously at two timescales, fast within-episode adaptation and slow across-episode weight updates. This emergent process replicates the beneficial effects of explicit metagradient methods without any of their architectural complexity. Looking at the within-episode dynamics reveals the learning process in action. Early in training, agents frequently attempt extortion as they probe their partner's responsiveness. As the episode unfolds, and they gather evidence of adaptive behavior, we see a graceful transition toward cooperative play, especially when paired with another learning agent, rather than a static opponent. These findings have profound implications for deploying cooperative AI systems at scale. By showing that standard decentralized reinforcement learning with sequence models suffices for robust cooperation, the work provides a practical path forward that naturally aligns with how foundation models are already trained. The key limitation is the requirement for sufficient diversity during training, which becomes a critical design consideration. Cooperation emerges not from complex coordination protocols, but from the elegant interplay of diversity, adaptation, and mutual shaping. Visit emergentmind.com to explore more cutting-edge research in multi-agent learning.